Hello, everyone. This is Khaja Abyan Ahmed, a student at the University of Houston. Uh, I'm here presenting you a PowerPoint presentation on on renewable energy integration into urban power grids as a part of my project of subject decision making and risk management, that is CNST 6350, Department of Construction Management. So let's get started. Okay. Now, to give you the abstract of the project, urban areas and major energy consumers and contributions to greenhouse gas emissions, making sustainable energy solutions essential. Smart grid optimize energy distribution, while microgrids provide localized resilient energy systems. You also learn about how this project provides a practical roadmap to help cities transition to renewable powered ecosystems, benefiting both the environment and urban communities. Okay, heading on. Now let's have a review of the literature, that is literature review. So we have seen that cities consume over 70% of global energy, making them key to addressing climate change. Now, economic barriers include high cost for infrastructure upgrades and energy storage solutions. Renewable energy technologies are becoming more affordable, but investment hurdles remain because it's a huge investment. Even though you'll have good returns, but the investment is still huge. Government incentives and public-private partnerships are essential to overcome financial challenges. Combining smart grids, microgrids, and financial support can lead to cleaner, more sustainable urban energy systems. Okay. Now, we'll look at the data representation. We have solar power, wind turbines, battery storage, their capital cost, that is per kilowatt, and the CO2 reduction per kilowatt, that is in tons. And their maintenance cost, that is in dollars. And also, let's see the final allocation. So this achieves the minimum cost, meets or exceeds the CO2 reduction target, respects the budget constraints, necessary parameters, and etc. Now we come to graphs. So as you can see in the first graph, wind turbine dominate the allocation of resources with the highest investment, significantly outperforming solar power and battery storage in funding due to their efficiency in achieving CO2 reduction goals. Whereas in the second graph, you can see wind turbines have been allocated the entire resource capacity, approximately 25,000 kilowatts, indicating the dominance in the energy strategy due to the high efficiency and significant CO2 reduction level. Okay. Now, solar power and battery storages contribute no CO2 reduction, highlighting their exclusion in this strategy due to either cost or lack of significant emission benefits. Okay. Now, coming to challenges in renewable energy integration, um, we come across many challenges, but some of our solar and wind energy production is inconsistent due to dependence on weather conditions, and plus traditional grids designed for centralized fossil fuels are ill-equipped for distributed renewable systems. Now, high initial cost for renewable technologies and infrastructure upgrades hinder adoption, that is basically financially constrained. Now, public resistance to new technologies is also there. Then energy storage technologies are costly. Then you have smart grids and bidirectional energy flow systems. You also have strong policy support and financial incentives are needed to encourage renewable energy investment. Collaboration between government, private sectors, and communities is vital. Okay. Opportunities in renewable energy integration. So, decentralized energy projection, localized energy systems enhance, smart grid systems simplify the integration of variable renewable sources like solar, wind. etc. You also have advanced energy storage solution. You have energy storage technologies, renewable energy policies, renewable energy projects. You have renewable technologies that contribute to significant emission reductions. So there are a lot of advancements. So basically, these advancements help cities transition to sustainable, resilient energy systems for future generations. Okay, coming to economic and environmental impacts. So, solar power installation costs range from 1,500 to $2,000 per kilowatt, while wind turbines cost between 1,200 to 1,800 per kilowatt. Upgrading grid infrastructure to renewable energy integration costs 50 to $100 million per city. By 2030, renewable energy adoption is expected to save 20 billion annually in global fuel costs. Renewable energy systems enhance climate resilience by providing stable energy during extreme weather events. Investments in renewable infrastructure yield significant economic and environmental benefits. Renewable energy adoption supports both environmental goals and energy security. Now, policy recommendations. Expanding of subsidies to support the installations of renewable energy systems, introduce government-backed green bonds, and mandate renewable-ready infrastructure in new buildings, standardize grid codes, implement vehicle-to-grid, that is V2G systems to allow electrical vehicles to serve as mobile energy storage, invest in research and pilot projects for wireless energy transfer to minimize physical reliance on physical infrastructure, launching campaigns for public awareness, promoting energy saving habits through workshops, uh, online seminars, lectures, etc. And by fostering renewable energy, cities can also enhance their grid efficiency, resilience, and sustainability for future generations. Now, we are at the conclusion. Now, integrating renewable energy into urban power grids is no longer an option. To make this transformation successful, a combination of advanced technologies, supportive policies, and active community engagement is essential. Smart grids, energy storage solutions, and decentralized systems play a key role in ensuring efficient and reliable energy distribution. At the same time, government must introduce incentives and streamline regulations to accelerate adoption. Here are the references which were taken for the PowerPoint as well as the report. Um, Thank you for the whole thing.